All right, I think I'll get started. Thanks. Thank you for joining me today for delivering quality at speed with GitOps. So just a few questions about you guys. I just want to know kind of what backgrounds you're from. Who here is kind of from the systems side, from the operations side? Okay, so that's the vast majority of you. And who of you have kind of somewhat used or familiar with Kubernetes? Okay, that's about right. I just wanted to make sure that I don't kind of use terminology that's unfamiliar with people. So I'm Brice. I work for a company called Weaveworks. We can find us online. And today I'm going to talk about an operational approach to managing kind of systems, particularly for Kubernetes. I guess it works really well with that. That's called GitOps. So this is the GitOps model. And the company and the people I work with are kind of responsible for putting it together and formalizing it, although it's a bunch of ideas that have been around for a while. So kind of why this talk? This talk is mostly about kind of giving you concepts and ideas, not necessarily kind of practical, here's how you do X. You're all smart, you can figure out how you do X in your own time. So this is more about the concepts and the impact of GitOps. So I think one thing that we kind of need to start thinking about is where we start is what is driving this? Why do we care, right? What's the biggest thing? The first one is we've got significant pressure on speed of delivery. I mean, that's not a surprise to anybody in this room. We need to kind of start upping the speed of delivery. Teams that are successful are orders of magnitudes faster than teams that are not in terms of their delivery speed. And this slide is from the State of DevOps report from 2016, so it's 3 years out of date now. It's even more impactful today, and it's even more important today. So that's one of them, right? We have a pressure for speed of delivery. And you need to be able to do it safely, right? If your systems keep breaking, speed is going to be a problem. The other one is microservices explosion, right? You have all these different cloud-native technology, and you have a sudden explosion of a whole bunch of stuff in your system. You used to be able to get away with knowing how to configure Apache, and now you have to understand the configuration for a whole bunch of different things, and it's getting complex. So the complexity is increasing in terms of our configuration management, and that's been a trend for some time now. And like this is a very, very simple picture of like some pipeline you might want. And you can see there are at least a dozen different things that need to be configured in a dozen different ways. And this is a pretty simple pipeline. So we need to start thinking about how to manage that complexity, how we managed all those configuration files in a structured way. So what's GitOps? So GitOps is an operations model. This is how you operate your infrastructure, right? Operations by pull request is the tagline. It's derived from kind of practical knowledge, so from operations knowledge at Weaveworks for a little while. For the past 3 or 4 years, where we've been operating systems, and particularly Kubernetes. And it's derived from kind of computer science stuff as well. It's essentially technology agnostic. It's not about Git, even if the name has Git in it. Git is just a tool to achieve a goal. It's a good tool to achieve that particular goal, but it's not the only one. And it's really about principle. It's about why. So hopefully, I'll transmit the principles to you today, and then the how you can figure out yourself. Obviously, we help with how, right? A lot of companies can help with how, Weaveworks being one of them. And we go back to one of the first things I mentioned was we need to kind of speed up our delivery cycles, and this is a way of doing it. So to start, I'll kind of like go through the principles of GitOps so you know exactly what I'm talking about. So firstly, the entire system is described declaratively. That might sound like infrastructure as code. In practice, what we've seen is infrastructure as code has been implemented by people, and what they end up with is a bunch of shell scripts in a Git repository to manage their infrastructure. This is not what we're talking about here. We're talking about data, right? Declaring your system, not just having a script that defines it. And that gives you some benefits, right? It's implementation independent. It's very easy to abstract. Data templating is very, very easy. It's easy to validate for correctness. Validating code for correctness is a bit of a pain, to be fair. That's actually very complex. Validating data is a lot simpler. And if you want to ask how complex it gets, just ask those guys. It's really easy to generate and manipulate data from code. Within the first 6 weeks of somebody's programming career, they're able to read and write structured data. This is basically what they have to do to kind of manage the infrastructure. So it means that the tools are accessible too. So how does it specifically differ from infrastructure as code, which has been around for a while? And I think this is kind of the infrastructure as code straw man. Infrastructure as code, as defined originally, has those properties, but what actually happens in practice is a little bit different. And what we really care about is consistency in the failure case. Shit goes wrong, right? All the time. It goes wrong when you're provisioning, it goes wrong when you're updating, it goes wrong. So what happens in the failure case? Well, if you've got an imperative set of scripts that change your system, what happens is you'll end up in a system that's in an inconsistent state. Something fails, your kind of provisioning scripts fail, and then suddenly your system is in an unknown state. You don't know what's going on. So having the declarations of your system means that you can start thinking about changes as transactions between two known states. And then you can let the machinery deal with failure to converge back to the state you desire. So that's a really, really good thing. So thinking of transactions and thinking of converging to a state are kind of some of the key ideas here. And so like you've got this declared state. It's very natural that you would version it, right? You put it in a Git repository. That's kind of the natural thing to do. It becomes your kind of canonical source of truth about the desired state of your system. The actual running state of your system only has one truth. That's the actual running system. But what you want the system to be like is now in a structured way. So for example, for Kubernetes, this works really well, right? Because we've seen deployments in companies where people manually change things on the cluster. They use kubectl because that's the tool that's shipped with the system they're running. And what happens is they don't really know what's running on their system. They don't even know what they want to be running on the system, which is really hard. So declarative definitions, you trivialize rollbacks because it's in Git, so Git revert. You've got good security guarantees for auditing, especially if you use signed commits. It lets you kind of build quite complicated processes around approval. So a lot of us have faced situations where we have a gated manual human approval process in the middle of our pipeline to move to production or to move to the next stage for whatever reason. We do it internally, right? We don't. All our promotion to production is done by a human. It's not done by a machine. It's all automated up to staging, but then a human takes it from staging to production. That's a really common thing. And so it's really easy to automate those processes. And because you've got this structured declaration that's machine and human readable, it becomes a really great collaboration point between software and humans. So we've all seen things like pull requests being reviewed automatically for securities by people like Sneak. We can do the same with now infrastructure. We can start validating infrastructure using the tools we've used for code for infrastructure. And the next step is the changes we make to the desired state in Git, so the repository, are now applied automatically to the system. And this kind of speeds up the cycle a little bit. As soon as you make a commit, it goes into a PR, it gets approved, it gets merged. When it gets merged, the system automatically updates. That's where you get some of the speed gains. This is quite nice. And I know a lot of you are already doing this, right? A lot of you have already started this. This is more encoding good practice than anything else in some cases. A nice property is that privileged operators don't cross security boundaries. That means the thing making the change to your system is in fact inside your system itself instead of outside it, which means the credentials to change your system are inside your system. They never leave because you're reacting to a state. So you can control access to that state in a separate way, and then the actual credentials, the keys, the authentication, the authorization lives in your system. So you have an operator inside Kubernetes, for example, that is reacting to change in a Git repository, and then that automatically updates your cluster. So it separates what and how, which is a good property. And the final bit is, now you've got this kind of nice state, this kind of utopia of I push to Git, it kind of updates. The next step is to alert on divergence and to have a continuous monitoring process. And this becomes very easy because you can go two ways. You can either take a declaration and turn it into a system, or you can take a system and turn it into a declaration. So to figure out what's gone different, the divergence, you just compare the two declarations. So this is kind of very easy to implement and put together. It's great at preventing operator errors. If you delete the wrong thing unintentionally, what will happen is your system will pick that up, say that's not the desired state, let me bring that back to you. So it's great for problem exists between keyboard and chair errors. It's essentially the control loop for your operations. So those are kind of the very quickly, the 4 principles of GitOps as I see them. And you'll notice I say approved changes to the desired state, because that's where your processes come in. You don't just have any changes being applied. So to kind of give that to put that into context with something a little bit more concrete, this is what some of the pipelines we're seeing look like. So you have the developer on the left who's pushing code to a code repository. The code repository is being built. The developer might have read-write access to the container registry for the artifacts. And then the CI pipeline has the credentials to modify the cluster directly. And that's a big deal, right? That's actually a big deal. These are the keys to the kingdom, essentially, especially if you're in production. So instead, what's the alternative? The alternative is you have the keys inside, and then you have the deploy agent, the agent inside your cluster with the keys, with the permissions, reacting to change in your configuration repository. And so you have a nice clean break between the two so that you don't transmit, your credentials don't cross boundaries. So the operator can then make changes to that config repository and change the system. But you can start doing some nice enforcement of process. It's much easier to enforce your process on a Git repository than it is to enforce the process on a bunch of commands run directly against your system. That gets very complicated very fast because it's kind of explosive in terms of how many things you need to control. Here you have a single point of control, which makes it easier for you. And you've got good auditing and good attribution, much better than you would if you were using command line tools. So I really like to think about it this way. It's like functional reactive programming, like React that we use for web apps, but for your infrastructure. It's kind of the same idea. You have this desired state, and then the infrastructure reacts to it. So what should be kind of GitOps? And I apologize for the term GitOps. That's terrible kind of murder on the English language. But essentially, what should actually be brought into that approach? So we've got some pretty standard stuff, Kubernetes manifests, Terraform, application configuration, provisioning scripts if you have them still. That's kind of standard, and we already do that, most of us. But we want to push that a little bit further. We want to push that into things like dashboard definitions, so that your dashboards are version controlled, they're in a repository, and then you can do interesting things because dashboards are template. Let's say you use Grafana, it's a bunch of JSON. You can start using templating for your dashboard, and I'll show you an example a little bit later. Alerts should be controlled as well. Your playbooks, the kind of living documentation that you run with your application, should be in your repository as well. And this makes it really nice. This has some nice property when you kind of put those things together, because you're going to make a commit that's going to include for a new service the code for the configuration for the service, the deployment for the service, the playbook and the dashboard and the alerts for the service, the monitoring, how do you do logging. All of that information is kind of correlated now. So you understand the scope of the change and the meaning of the change a lot better. And then you keep kind of going a little bit further even and do things like application checklists, which are your desired application model. How do you build a great application on your platform? You all already have rules in place in your company about what is a good production quality application. Well, you need to start encoding those and then checking those so that your pipeline, when you put a pull request for adding a new service into your infrastructure, your pipeline will come back to you and say, hang on a minute, you have not met those criteria that we desire for our production applications. And so that's some of the things we do internally is we have this checklist. And if your service doesn't match those checklists, the pull requests will be automatically denied by the CI machinery. So your pull request will fail if you don't kind of match the standards of the applications we want to deliver. And then we talk about things like sealed secrets. How do you deliver secrets? How do you version control secrets? How do you do it safely? And this sealed secrets is an operator that kind of plays well with that configuration-driven approach. So everything, right? We want to start bringing everything into this rational approach. The point being that we want our entire system to be git push to a new repository, have the agents react to it, and then spin everything back up. Let's say we want to move to the EU, right, to create a new data center because of EU legislation around data, which is somewhat relevant. Well, right now your cluster is in London or is in some other place in the UK. You should just be able to point it to a different, your entire infrastructure, your entire application, point it to a different endpoint in the EU, press a button and watch it go, because everything is configured and is in your repository. So what does that look like in practice? What do we kind of look like in practice? Let me show you some alerts on divergence. This is an example from our own Slack of something not being what we expect. In this case, it's a Terraform difference, right? So we're looking at differences in our running system and our desired system at all levels. And it starts from, the machines all the way up to the applications. And so this is an example of something that has changed and triggers an alert because we no longer, we can't manage the system in a healthy way because the system isn't the expected state. And most of those alerts would self-resolve because there's an operator in the background doing the work of bringing the system back into convergence. This is just an example of kind of the things you get. So what about controlling external systems, right? We have this nice little walled garden of ideology, I guess, around our own infrastructure, but how do you deal with kind of the external provider? So this is an example of what we're doing with things like GitOps to manage Git, which is an external system. So it turns out, so in this case, what we're doing is we're creating an alert that's telling us when the permissions in our Git repository is not what we expect. So we use GitHub. Let's say somebody, by mistake, grants permission to an external contractor or maliciously grants permission to somebody that shouldn't have permissions. Because we've got this declared state, this will trigger an alert. So if I go in right now and change some permissions in GitHub, an alert will pop up in our operations Slack telling, hey, the permissions are different. Something should be done about that. So this is an example of a Terraform file with me and my role in the organization. In fact, because we've started using that approach, we could reduce that role. So now that's out of date. I'm just a normal member of the organization. We've reduced the set of permissions because it's so well driven. I can create a pull request against those repositories because I have visibility on them, but I can't modify them. I can't mutate them. So it leaves you with a state where the people who can mutate your system is smaller, but the people who can view your system can be larger, which is a little bit, it's an interesting model to think about. So how do we kind of apply this approach to dashboards? Well, we've built a tool called Grafana. I mentioned templating before. Grafana is a tool that lets you template Grafana dashboards. And so we have this thing, and if you squint, you can see it's basically data. It doesn't really matter what it is. What I'd like to highlight is this. This is one line. This is a query per second graph line with some arguments. And that turns into that graph. Right? So we can now, because of data templating, we can start doing some very sophisticated things to speed ourselves up. When we have a new service, it's really easy to put dashboards together to monitor that service because we've got those templates. That line, for example, encodes the RED approach. RED is requests, error rates, and delays or latency. So this is kind of our monitoring dogma, if you want. And we've encoded that into a single line in our provisioning. So it's really, really, really easy to create a set of graph that matches for every service. So now every service we have has that exact set of graphs. So the operators, because we've templated it, because we've made it really easy to use, the operators of the system can recognize what they're looking at no matter where they go in the dashboard, because all the services are using the same template. So this is quite a nice way of making the life easier for your operators. So what does that kind of turn into? We've got a whole bunch of stuff that we do around GitOps, and you don't really have to read what's on the left. But what really that turns into in practice is we can recover a total failure. That means we delete our root AWS account in about 30 minutes, from 0 to having our entire infrastructure back up in about half an hour. And that has been tested in anger in the past. Data permanence, the data loss, that's another issue. That's much more complicated, but the actual running system can be recovered in 30 minutes. We make dozens of changes on the infrastructure itself per day with a very small team. In terms of the regression response time, the kind of time it takes for you to fix a customer visible problem, I've been in a meeting, in person on the phone, on Skype, with a customer, and something went wrong, right? They were trying something out, something went wrong. So I jumped on Slack and said, hey, we've got something wrong with this particular customer, with this particular version of our software. They said, OK, we just went into the UI, click revert. That created the whole machinery. We just created the commit. And I said, just reload your page, and the issue is gone. Like, that's an experience that's incredibly valuable when you're talking to a customer and say, just refresh the page, and the issue will be gone. It's very permissive in terms of production access, right? Read access can be had by a lot of people without reducing your security model, which means that it's easier to propose changes because you have good visibility over the entire infrastructure. You have better context. It's a good developer experience because it's using the tools they're used to, so that developers can propose changes to infrastructure if they need them, and that can be reviewed by your operations team. And it's a mostly stress-free on-call because you have really good tools to revert things back to a known good state. I mean, it's stress-reduced, I guess, rather than stress-free. So how many minutes do we have? We've got a little bit more time. Perfect. So let's talk about what that actually turns into in terms of transformations. This is a team that Cordoba that adopted this approach. And they managed to kind of get significant velocity gains in terms of actual releases deployed, while increasing velocity and reducing defect rates, which is quite impressive. So from 2 to about 150 deployments per week, while reducing the number of broken deployments, which is a big deal, right? And the reason is you're automating part of that cycle, right? You're automating part of that cycle. You're making it safer. You've got software making commits to change your infrastructure, to be reactive to new versions, safe and reversible changes, automated templates and dashboards. So the feedback loop, that's what matters, right? If you can get that inner loop faster, that's going to speed up your entire organization. OK, so to finish off, so we can leave a couple of minutes for questions, what is GitOps? It's an operational approach based on coherent principles. It helps manage the complexity of modern infrastructure, and it speeds up development by providing safety and enabling great automation with kind of that's easy to put together. And that's it. So now we've got about 2 minutes for questions. But otherwise, you can get hold of me on these things. Just search Weaveworks GitOps. You'll find tons of resources. So yeah, I think you had a question.
Your top 3 bots for GitHub.
Top 3 bots for GitHub.
Top 3 bots that changed your life.
I really like, I can't remember what it's called now, but there's a Terraform operator that automatically applies Terraform from your GitHub.
Atlantis?
Yes, thank you. It's Atlantis. That's right. So Atlantis, I quite like Atlantis. Not in this job, in a previous job, I really like the Sneak tool to do reviews of the code. That picked up a bunch of quite severe bugs in my case in a previous job. The third one, I'd say Flux, which is the one like we put together, which reacts to changes in Git and brings them to your cluster. So yeah,
Thank you.
top 3.
How you can implement that model if you're not using Kubernetes and Terraform?
So I'm just repeating for the recording. So the question is, how do you implement the model when you're not using Kubernetes, Terraform, etc.? And the answer is it's hard, right? Legacy systems that don't use that kind of approach tend to be harder to manage. You can build the declarative layer on top, and that can work well. For example, that's the GitHub stuff. What you do is you create a Terraform provider on top of whatever resource you're doing, and that can be incremental. You don't have to kind of go all the way to start with. You can start in slices. So using an existing tool and building a provider for it tends to be a good bet. For example, DNS. Most DNS can't be configured declaratively, but what you can do is you can create a declarative configuration of what you desire your DNS to be, and that's the first step in kind of double checking. And that could be, you can start with a manual process, right? And then automate some of the checks, automate some of the applications. So for example, a great example of that is the external DNS for Kubernetes, which does exactly that. It lets you configure imperative systems, DNS system like Power DNS, whatever, DigitalOcean, whatever it is. It lets you configure those by calling their API, but using a declarative configuration. So that's kind of the model of how you'd move that forward. But it is hard, like no mistake, that's just tough.
So in a cloud-native landscape where you've got dozens to maybe hundreds of different services, you're saying contain all of the logic for deployment within each service?
So do you mean like in how you structure where?
One service, and then it goes through CI,
Yeah.
the deployment aspect of that, what triggers that?
Okay. I'll grab you just after I think we're being asked to wrap up. But do you mean like?
So I'm just curious, if I put the deployment steps to say notify an operator there's a new version inside each service, how do you then orchestrate the disaster recovery in under 30 minutes?
You have your configuration in a single place. You have a single canonical place for your entire cluster. Short answer. Thank you very much. I think we're out of time, so thank you for your time.